I wanted to do. So we are looking at writing and solving inequalities in one variable. So if we're looking at this warm up, this getting us ready for math this morning. So Kieran is getting dinner for his drama club on the evening of their final rehearsal. The budget for the dinner is at most $60. Okay, think about what that word, that phrase at most means when we're talking about inequalities. Okay, that's what a first thing I want to point out to you today. Okay, so Kieran plans to buy some prepared dishes from a supermarket. The prepared dishes are sold by the pound at $5.29 a pound. He also plans to buy 2 large bottles of sparkling water at $2.49 each. Okay, so he's buying 2 that cost $2.49 each. What I want from you on the next slide is I want you to go back and forth between these 2 slides, and I want you to first represent the constraints in the situation mathematically. If you use variables, specify what each one means. Okay, so we have these inequality symbols above for us to use. What I want you to do is I want you to write an inequality that, or inequalities, more than one, that represents this scenario here. There might be one, there might be like one large inequality that you can write. There might be 2 smaller ones that we might have to put together. So first, I want you to write an inequality or 2. Nice job, Kyle Kelly. That represents this story. Please, if you use a variable, please let me know what that variable stands for. And then I want you to find the solution to the inequality. How many pounds of prepared dishes can Kieran buy? Explain or show your reasoning, okay? So I want you to take 2 minutes right now to first write your inequality, then to solve it. If you need to insert a box for your work on the side over here, you can do that. I want you to take 2 minutes right now to work on this. Once you get some inequalities, let me know in the chat. Nice job, Peyton. That's a good one. I want you guys to, if you write 2 inequalities, it's okay, no problem, Peyton. If you write 2 inequalities, once you finish, I want you to look back and think, hey, can I write this as one big inequality? I don't know. Nice job. Another minute, guys. Okay, we have 30 more seconds. I want people to put those inequalities in the chat, please. Nice job, Gabe. Okay, what I need you to do now, I only have 3 people that put theirs in the chat. I want you, if you did not get a chance to put yours in the chat, put it in the chat for me right now because we're going to start to talk about it, okay? So, nice job, Abby Watson. Nice job, Connor. Nice job, Ian. That's okay if your symbol didn't go in there. I know what symbol you guys are talking about. Nice job. Nice job, Kyle Kelly. Okay, wonderful. So, let's take a look at some of these inequalities that we could have written here, right? So we could have written 2, right? We could have written one that was just, that represented, so we had two sort of paragraphs here. We said the budget was $60, and then we had some more specific information about that story, right? So we could have written one of 60 is greater than or equal to that greater than or equal to that budget, right? We could have written it as that B budget, right? And then we could have written one that was more specific with all of those, the cost of things. What I want us to do is I really want to push us. Yes, very good, Abby Wasta. One thing I really want to do is I want to push us to sort of condense these guys and make one or two real big inequalities that could represent the story, right? So $60 is the most that it can cost. And we know that what we're gonna add up together to be that $60 is that how much was it per pound, Miss Charmaine? $5.29. So we're going to say $60 is greater than or equal to $5.29. And then we can pick a variable. Some friends used X. Plus, he's buying those two bottles. So each prepared dish is $5.29 plus that $2.49 times 2, right? $2.49 times $2, 2 times the two bottles that he's buying. Can I simplify this even further? Because we're saying $60 is greater than, what do you think, Gabe? Why don't you unmute and tell us, how could we simplify this even more?
Multiply the 2.49 by 2 to get 4.98.
Okay, very good. So you could simplify it and do that multiplication, and you would get 2 times 249 times 2 is going to get you 498. So we could say 4 plus 498. Very good. And so we would have this inequality here of $60 is greater than or equal to the 529 X, because X represents our number of what? What would X represent in this scenario? Very good. The number of pounds of pre-packaged foods that he's buying, right? The number of pounds of prepackaged food. Good, because we're talking about the number of pounds times that 529 per pound. Good. And then if we were to solve this guy for X, we would subtract 498 on each side. Very good, Peyton. We would subtract 498 on each side. So 60 minus 498 gets me 5502. And then we would have to divide that by 529. And we would get, here's the deal. This is where the tricky part comes in. We would get 5.4, right? So can we round it up to 11 pounds? Can he buy 11 pounds of stuff? So if you look at the number that you get when you divide, I got 9.4, right? If I rounded it, 9.4. Can I round that up and say I'm going to buy 11 pounds of food? Is that possible? Does he have the money to buy 11 pounds of food? No. So if we wanted to round it down to the nearest pound, we would have to round it to what? How many pounds? Nice job, Sadie. Sadie's saying that no, we couldn't because you would go over the amount of money. Good, because it cannot be larger than $60. So if I were to round it to the nearest pound, what pound would I have to round it to? 10.4 rounds down to 10 pounds. So I would take the answer of either 10 pounds or I would take the answer of 10.4 pounds. Pounds of food. Okay, so we're talking about in solving for that number of pounds that we can buy here. Okay, nice job on that one. Very good, guys. Nice, nice, nice. Is anybody confused as to how we solve this guy? I think that as we're going through the solving of inequalities, I think we're going to have a pretty good time with it because you guys are very good with solving equations, with like maintaining your equity. So this is very much the same as like when you're doing something to one side of your inequality, you're doing it to the other. So you're maintaining your equity in the same way. The only thing that we need to keep in mind is that if we multiply or divide by a negative number, we just need to switch our sign. Boom. That's the only thing we really need to keep in mind. So I think we're going to be feeling okay with this. Ava, how you doing, my friend? I think this is so this is where you shone on the midterm. So I feel like you're going to do fantastic on this piece of this unit. So that just wanted to sort of point that out because I thought that was really cool. So if we're looking at our learning targets for today, our learning targets are, number one, I can analyze the structure of an inequality in one variable to help determine if the solution is greater than or less than, or greater or less than the solution of the related equation. So just like we were doing in class on Friday, we were taking a situation, we were writing an equation out of it, right? And then we were turning it into an inequality. And then to find out the solution to that inequality, we were solving the equation. And then we were plugging in values to determine, is it going to be less than that value or greater than that value? We're going to be doing something very similar again today. So awesome on that. And you can write and solve inequalities to answer questions about a situation. Okay. So it's going to be a little bit, I like it. It's going to be a little bit fun in the way that we're going to be writing our own inequalities now. And they're going to be sort of more complicated than the ones that we were writing before, where we were saying like x is greater than 2 or x minus 2 is greater than 77. They're going to be a little bit more complicated in the way that we're going to have like a rate of change with a variable plus like a constant, or there might even be some parentheses in there somewhere. So buckle up. It's going to get a little bit crazy. Not too crazy though. Okay, awesome. So now we're going to be talking about a gasoline tank. We're going to be talking about like we're mowing the lawn. I don't know why you don't rev thing, whatever. So we're going to be mowing some lawns, right? So Han is about to mow some lawns in his neighborhood. His lawnmower has a 5-gallon fuel tank, but Han is not sure how much gasoline is in the tank. So how much can he have in his tank if it was completely full? Taking that piece of information. If he were to have taken it out of the garage or wherever he stores it, and it was completely full, how many gallons could he have? Wow, Kyle Kelly is ready. He could have up to 5 gallons. Nice job, Gabe. So he could have up to 5 gallons in there, but we don't know how much he has. So he knows, however, that the lawnmower uses 0.4 gallons of gasoline per hour of mowing. Okay, it uses 0.4 gallons. So think about what that term, what that idea of it using gasoline might look like if you were writing about like a rate of change. Write one or more inequalities to represent your response. So we're trying to figure out how many hours can he mow his lawn for. We're creating an inequality for the number of hours he can mow his lawn for. So what I want you to do right now is before you even start to solve it, I want you to take 1 minute right now to first write an inequality. I'll try to stick with one inequality that we can use for this situation. It says more than one, but I want to push you to be concise in your answer, to take 1 minute and write an inequality that represents this scenario here. Good. Okay, Gabe gave us one. Let's see. What are these inequalities that we could write here? Okay, so I have one friend in the chat that gave me an inequality that matched this scenario. I want to see if other friends can tell me some an inequality in the chat for us as well. So what I like about Gabe's here is that, nice job, Peyton. Yes, that's fantastic. That's exactly what I'm looking for. So if we look at this idea, this concept that Gabe put in the chat here. So I think that obviously when you put things in the chat, the or equal to doesn't show up. So let's take a look at what Gabe was thinking here. So Gabe said 5 gallons, because that's the most amount of gallons that he could have, is greater. Actually, I'm going to write it in this box right here because I want to bring my symbol down here. At 5 is greater than or equal to. Very good. And we're going to use that or equal to because he literally could have 5 gallons in his gas tank. He could have less than that, but he could actually have that 5 gallons in there. And then Peyton said, so 5 is greater than or equal to 0.4x, where x would represent our what? What do we think our x would represent, Pete? Or Gabe, you said h. What would your variable in this scenario represent?
The hours that Han mows.
Very good. Nice job. Exactly. Perfect. Nice job, Junior. The gas used per hour of mowing. Yes, very good. Very good, Peyton. Nice. So that X is going to represent the number of hours that he's mowing. Good. And so we're going to say 5 is greater than or equal to 0.4x. So now I want you to take that inequality and I want you to solve it. And I want you to figure out how many hours can he mow his lawn for. So I want you to take 1 minute right now to solve that inequality. I'm doing it in this box next door. You can insert a box if you would like and type it in there because it might be a little bit easier. Let me know in the chat, how many hours can he mow his lawn for? Thinking that it's not going to be an exact, write your answer. Your answer needs to be written as an inequality because remember, it's a range of times. So you're not just going to say 14 hours. You're not just going to say 20 hours. You're going to say, write it as an inequality. Okay, I want you to take another 20 seconds right now because I want to make sure that you're writing your solution as an inequality. You're not just telling me 17 hours. You're not just saying 22 hours. You're giving me an inequality that represents that solution set, that range of data that could be the solution to that inequality. So I want you to take another 20 seconds to write it as an inequality, making sure your symbol is going the right way. Okay, Kyle, do you mind unmuting, my friend? Perfect. So Kyle, I have 5 is greater than or equal to, I just couldn't get the little line, 4.4x. So what did you do to get that x by itself?
Divide by 0.4.
Nice job. You would divide each side by 0.4. Very good. So if you divide by 0.4, divide by 0.4, Mr. Main, 0.4, you would get, actually, I can go like that. Oh, that just made me think of Connor because he told me that the other day, and I knew that. I would get, what is greater than or equal to what? What did you get for an answer there, Kyle?
12.5.
12.5 is what?
Greater than or equal to x.
X, very good. And remember, we need to write our solution as not a single value. So like if he had 5 gallons, then it would be 12.5 hours. But because we don't know how many gallons he has in his tank, we're not going to be able to say like it's a definite answer. It's going to be a solution set because it's from anywhere from this to this number of hours. Okay, so we want to make sure that. Very good, Max. So my trick, and Connor told me this the other day, I knew this, but I wanted to make sure I give Connor credit, is that if you don't know how to do the symbol here, if you do like the greater than symbol and then you highlight it and underline it, you get it and it's greater than or equal to. So I don't want to, I mean, I knew about it, but I want to make sure that I give credit to the person who showed it to everybody. Is 12.5 is greater than or equal to x. So x is never going to be larger than 12.5. And it's funny because Peyton said it the same way, except she said it opposite. She said x is less than or equal to 12.5. And both of those mean the same thing. So if you wrote it like this, let me rewrite it. Let's rewrite it. What if you wrote it like this, it would still be the same solution. So like in here, if I were to click down here and I said x is less than or equal to 12.5, that would still get me the same, that would still represent the same solution set if you put that x first. So both of these would be solutions to this inequality here. Okay. Nice job, Max. I love it. So here's the dealio. We're going to look at, and we're going to take a look at Andre and Priya. Okay. There's a lot of words here. So what I want us to do is we are going to take this one step at a time. Okay. And we're going to be looking at Andre and Priya. They used different strategies to solve the following inequality, but reached the same solution. So we are going to look at first. Nice job, Kyle Kelly. So we're going to look at Andre first. So we were given, this is our inequality here. Okay. And Andre and Priya obviously took 2 different steps to solve it. So I want us to look at what Andre did first. So let's take a look at what Andre did first. I want you to take 1 minute right now to analyze Andre's steps and try to come to a consensus as to what did Andre do here when he solved. Okay. Nice job. I want you to take 1 minute right now. Nice job, Peyton. Okay, here we go. Okay, so let's look at Andre's steps. Okay, so we're going to start at the top and we're going to work our way down. So from step 1 to step 2, Andre did what? Andre distributed. It looks to me like we simplified the left side of this equation. We multiplied 2 times 2x, 2 times 1.5, and we got 4x plus 3 is equal to 18 minus x. 4x. Yes, very good. Nice job, Max. Then from step 2 to step 3, oh goodness, what did we do here? Nice job, Max. Max says we subtracted 18 from both sides. Yes, that's exactly correct. Awesome, awesome. So then we subtracted 15. No. Let's see what we did here. Okay, so we went from some 2 to 3. We subtracted 18 from each side. Now 3 to 4. What did we do 3 to 4? Very good, Gabe. Yes. And Max, we subtracted 4x from each side to get negative 15 is equal to negative 5x. And then we said 3 is equal to x. And Priya took the same steps to solve it. So if we look at Andre and Priya's first step here, what we started with this inequality, what was the first thing that both of them did with that inequality in order to solve it? What did they do with it? They turned it into what? Look what they did here. We went very good. They changed it first into an equation so that they can easily solve it without having to deal with that symbol and remembering to flip it. So what we want to do is when we're given a really complicated guy like this or inequality like this, it's always a good idea to sort of change it into an equation, because then you don't have to deal with flipping your signs or having to remember all those extra sort of inequality rules. So my suggestion is to sort of turn it into an equation just to find the value that it's going to be equal to. So in this case, if you were to write it as an equation, it would be your solution would be 3 is equal to x. So now you have like a value where your point is going to be. Whether it's an open point or a closed point, we don't know. Actually, we do. It's going to be an open point. So we know where our open point is going to be. We just now need to figure out which direction is our line going to be moving, which direction is our inequality symbol going to be facing. So this is where Andre and Priya did some different things. If we look at Andre here, he tested to see if x equals 4 is a solution to the original inequality. So here is the dealio. This is basically what Andre did. Andre turned it into an equation and found that value that it was going to be equal to. Where is your point going to be? Okay. Then he said, I'm going to test it. I'm going to test a point that comes above it, a point that's greater than it. And I'm going to see if I plug it into that original inequality, is it a true statement? So if we look at when he plugged in this 3 here into the original inequality, we would say I think we're missing an x here. I think there was supposed to be an x here. Yes, there was supposed to be an x there. So we would say 2 times 4 plus 1.5. So you would do all of that in the parentheses first. 8 plus 1.5 would be 9.5. Multiply that times 2 to get a 17 is less than 14. Is this a true statement though? Is 17 is less than 4.14 a true statement? No. Very good, Gabe. Thank you for that. So nice job, Ian and Max, on that one as well. It's not a true statement because 17 is larger than it. So if we said that x is not going to be, or 4 is not going to be a solution, then so if we're looking at a number line here, let me just draw one quick here. Okay. We have 3, 4, and 5, or 2. Okay, we have 3, 4, and 2. Let me just hold it up real quick. Okay, so our point is going to be on that 3. We see that point, and we just tested 4, and we found it was not a solution. So which direction is my line going to be going? Towards the 4? When I draw my inequality line on here, is it going to be going towards the 4 or towards the 2? We just tested number 4, and it was not a solution. So when I draw my inequality, which direction is it going to be moving? Towards the Very good, Connor. So we just went into that inequality and we tested the number 4. We found it was not a solution. And we know when we're talking about an equation line or an inequality line, that a solution is going to what on that line? Solutions always fall on that line, right? So if we said that 4 was not a solution, then our line cannot be heading in that direction because it can't hit 4. So it's going to have to fall. It's going to have to go backwards towards this 2. So if we were to write an inequality that represented the solution for this equation, what would the inequality be? This is just on my forehead. Do you guys see what I'm talking about though? Because I like this. I actually like this equation here. Okay, so if I were to write an inequality that now so because 4 is a no-go, it's not going to work. It has to go towards 0, right? So if I were to write an inequality that represented this graph here, what would the inequality be? 3 is what? 3 is what as compared to x? Is 3 greater than or less than x? Looking at our graph, in what direction it's moving, what would our inequality be? Very good. Nice job. Nice job, Connor. So 3 is greater than our x because the x value, our solutions are less than this 3. So we can say 3 is greater than x, or you could write it the other way and say x is less than 3. Both of these inequalities would be the solution to this guy here. Okay, so what I'm not going to do, I'm not going to go into Priya's explanation of how she did it, because I think that Andre's way of throwing one of these points in and testing it is probably going to be an easier way for you guys to do. So what we're going to do when we're back in school, we're going to do some more examples tomorrow we're still going to be doing some examples, but I'm going to really, when we're back in school, I want to do one more of these together so that we understand the steps of it. So we're going to keep doing work with this in the future, but awesome job with this today. So what we're doing here really is we're turning it into an equation and we're finding that value the solution to that equation. And then we're going to test a point that falls above, and we're going to determine, is that a solution? And then that's going to tell us which way on our number line is our line going to go from that point. Does that make sense, you guys? I kind of like it. I kind of like that way of thinking about it. And we're going to do some more practice with this tomorrow. This afternoon, let me do a quick rundown of what you're going to be doing this afternoon, okay? So you are you don't have to do anything on slide number 7 because we just talked about how Andre solved it and we didn't really want to look at Priya. So if we look at our afternoon work for today, there is a link to a video in there, okay? You have 4 inequalities that you have to solve. I built time into the video for you to solve them. I go through the answers. Then you have 6 inequalities here. It's going to be your job to solve those 6 inequalities and to match them to the equation, like the graph of the inequality to the left here. Once again, I'm going to go through the explanations, so don't fret about that. And you're going to be in the video and you're going to be checking your work. Okay, and then last is the warm-up, the cool down on slide number 12, which will be independent, which you are going to be creating an inequality based on this scenario here, just like we did in the first activity this morning. You are going to be creating an inequality here based on this scenario. This one, I'm not going to give you the answer to. We're going to go through it as the warm-up for tomorrow. Okay? Is everyone clear on what you need to do this afternoon? Awesome. Okay, so I'm gonna hold an afternoon session this afternoon, but I'm really gonna try to focus on pathways because we have a quiz tomorrow. But if you have questions, I'm gonna post a link to an afternoon session if you want to jump in. And please let me know if you have any questions. The video is like 24, but you can skip around if you'd like. If I put work time in there, so if you want to like skip through the work time a little bit, if you finish early, please feel free to do that. Okay. Awesome. If there are no other questions, I'm going to stay in here. But if you don't have any questions, you can head out to science class for today. I will see you tomorrow. I don't know if we're going to be back in school though. Bye, guys. Bye. How you doing, Max? Destiny, Jalen, Melissa. Good morning, everybody.
Good morning.
It's so good to see your beautiful faces. Please open up the slideshow for this morning. Edgar, Melissa, Geostorm is here. Good morning, Matthias, Joe. I think I got a little bit lost for a second. Landon, Rashem. Jalen is joining. Sam B is here. It is so good to see everybody this morning. Good morning, Joe. I love your hat. Let's see if Jalen will be able to join. He's still joining. No problem, Joe. You're fine. Okay, let's open up the slideshow for today. I am going to do one thing right